Hello, my dear students. Welcome back to Fluid Mechanics lecture series. I am your SumamMiss. My channel name is also SumamMiss. You can watch all my videos on my channel. If you found useful, please don't forget to like, share, comment, and subscribe. Today we are going to start the discussion on open channel flow. What is an open channel? It is a sloped liquid flow passage having solid boundaries with top surface exposed to atmosphere. So in the previous sessions, we have learned about the flow characteristics in pipes. The flow in the conduit may either classified into pipe or open channel depending on whether it runs full under pressure or it has a free surface. For example, a sewer or a drainage pipeline under ordinary conditions of flow, it behaves as an open channel, while at the time of heavy rain, the sewer is completely filled with water and runs full under pressure. So, we can define as open channel is a conduit where water flows with a free surface. So, the free surface is defined as the surface of contact between the liquid and overlying gaseous fluid. In most of the engineering problems of open channel flow, this gaseous fluid happens to be air at a local atmospheric pressure. So in a nutshell, we can say open channel is a conduit in which water flows with a free surface. So this fact that the flow in an open channel must have a free surface distinguishes it from pipe flow. What is the importance of analyzing the open channel flow? The prediction and analysis of the flow characteristics in an open channel flow is of significant engineering interest, and it is required in the design of canals, culverts, sewers, dams, weirs, etc. Now let us discuss the major difference between open channel flow and pipe flow. The open channel is a conduit in which water flows with a free surface, whereas in pipe flow, the pipes runs full under pressure. So figure shows a pipe flow segment. Two piezometers are inserted at the section 1 and 2. The section 1 is at a distance of Z1 with respect to the datum, and section 2 is at a distance of Z2 with respect to the datum. And the corresponding pressures at the section 1 and 2 are indicated by P1 by rho g and P2 by rho g. And the velocity head is represented by V1 square by 2g and V2 square by 2g. This dotted line represents the total energy line. If you are neglecting the friction losses between the section 1 and 2, the total energy at the section 1, that is P1 by rho g plus V1 square by 2g plus Z1, that is equal to P2 by rho g plus V2 square by 2g plus Z2. In pipe flow, the flow is taking place under hydraulic pressure. So you can see that pressure is getting decreased in the direction of the flow. Whereas, so open channel is a conduit where water flows with a free surface. This figure shows the flow segment of an open channel between the sections 1 and 2. This fact that the flow in the open channel must have a free surface distinguishes it from pipe flow, which runs full under pressure. In open channel, the flow is exposed to atmosphere, so the pressure distribution in straight continuous bottomed channel follows hydrostatic law. So pressure at this point, that is equal to rho g y1, and pressure at this point, that is equal to rho g into y2, where y1 and y2 are the depth of the flow at the section 1 and 2. So the flow in the open channel is taking place at the expense of potential energy, and hence the flow is caused by the gravity force due to the sloped bottom of the channel. So this line represents the total energy line. If we are neglecting the losses between the section 1 and 2 and equating the total energy at the section 1 and 2, then y1 plus v1 square by 2g plus z1, that is equal to y2 plus v2 square by 2g plus z2. So if you are comparing the total energy equation of pipe flow with respect to that of open channel flow, then we can write P1 by rho g is analogous to y1 and P2 by rho g is analogous to y2. That is, the pressure head which is indicated by the piezometric level at the section 1 represented by the flow depth in the open channel. Since in open channel flow, the flow is exposed to atmosphere, the water surface is coinciding with the hydraulic gradient line. Whereas in pipe flow, The line joining the piezometric level represents the hydraulic gradient line. Another thing is in pipe flow, the cross section is always circular, whereas in open channel different shapes are possible like triangular, rectangular, circular, trapezoidal, etc. And in the case of open channel, the surface reference varies in wide range. So if we are considering the velocity profile in pipe flow and in open channel flow, then you can see that in pipe flow, velocity increases from the boundary to the maximum at the center. So it follows a parabolic profile at this section, whereas in open channel flow, velocity increases to the maximum, then it gets decreased towards the free surface. And this velocity profile is also varies, depends upon the shape of the channel and roughness of the channel and alignment of the channel, etc. So for analyzing this open channel flow, we should know the geometric elements of different shape of the channel and the corresponding geometric parameters. In the next section, we are going to discuss about different type of channel and geometric elements of channel section. So channels are classified into natural channels and artificial channel or man-made channel. So reverse streams are examples of natural channel where the cross section, slope, etc. are changing from section to section. So analysis of natural channel is complex compared to the artificial channels. So artificial channels or man-made channels, so we can maintain a constant shape and slope throughout the length of the channel. So if we are able to maintain the constant shape and slope throughout the channel, then that type of channel is called prismatic channel. Otherwise, it is non-prismatic channel. So natural channel is a non-prismatic channel. The different shape of channel possibles are, that is shown here, that is circular, rectangular, triangular, trapezoidal and natural. So geometric elements for a circular channel, it is defined by the diameter of the channel. For a rectangular channel, it is defined by the breadth and depth of the channel. And for a triangular channel, it is defined by the flow depth y and the side slope m. And for a trapezoidal channel, it is indicated by the breadth, the side slope and depth of the channel. And another thing is wetted perimeter. Wetted perimeter is the length of the channel boundary which comes in contact with the flowing liquid. In addition, we have to define the wetted area or area of the flow section, which is the cross section area of the channel normal to the flow. So wetted area is defined by this area which is normal to the flow direction. So you can see that for this channel cross section area and the slope, that is constant along the length of the channel. So this channel is prismatic channel. Next part, we are going to discuss about the geometric parameters of the channel. The first geometric parameter is hydraulic mean depth or hydraulic radius. So it is normally denoted by capital R. So R, that is defined by A by P, where A is the cross-section area of the channel and P, that is the wetted perimeter. Consider a rectangular channel. So area, that is equal to B into D, and wetted perimeter, that is equal to B plus 2D. So hydraulic radius R, that is equal to A by P. Next parameter is top width T, that is width of the channel at the free surface. So in the case of rectangular channel, since bottom width and top width are same, whereas you can see that in the case of trapezoidal channel, top width is different from that of bottom width. So hydraulic depth D, that is equal to A divided by T. A is the cross-section area and T is the top width of the channel. Another geometric parameter is the bed slope. So this is the longitudinal section of the channel. So elevation difference between these two sections, that is equal to Z, and the length of the channel, that is equal to L. So bed slope S0, that is equal to Z by L. If theta is very small, instead of tan theta, we are representing that as sin theta. Next geometric parameter is the section factor. It is denoted by Z. It is a product of wetted area and the square root of hydraulic depth. So hydraulic depth equal to A by D. So Z equal to A into root of D, or that is equal to A into root of A by D. So in open channel, different shapes are possible. So one should know about different geometric elements and geometric parameters for solving the problems. Another geometric parameters of open channel is one is depth of flow and another is depth of flow section D. So depth of flow, that is the vertical distance from the free surface to the lowest point on the channel bottom. So it is indicated by Y. So Y is the vertical distance from the lowest point in the channel section and the free liquid surface. It is different from depth of flow section D. So depth of flow section D is the vertical distance which is normal to the flow. So this is the flow direction, and depth of flow section is represented by D. So D is the actual depth of the channel measured normal to the direction of the flow. So we can relate Y and D as D equal to Y cos theta. But if theta is very small, then we can equate D equal to Y. Now let us discuss about the velocity distribution in open channel flow. So as we have discussed earlier, velocity distribution in open channel flow depends upon the type of open channel. So channels are classified as rigid boundary open channel, loose boundary open channel and prismatic open channel. So in open channel, surface roughness varies in wide range. So the factors which are affecting the velocity distribution in open channel flow are shape of the channel section, roughness of the channel, alignment of the channel and slope of the channel bed. So the figure shows a natural channel where you can see that roughness varies in wide range and alignment also changing. The slope is also changing and the channel section is also different from section to section. Whereas in this figure you can see a prismatic channel. So it is maintaining a constant shape and it is a lined channel, so roughness is constant. So velocity distribution here is more or less uniform. Now let us discuss about the velocity distribution for different shape of the channel. So the figure shows rectangular channel, trapezoidal channel, triangular channel and circular channel. And you can see that the velocity increases from minimum to the maximum, then it is also getting decreased. So velocity increases from 0 at the boundary to the maximum value, then it is getting decreased when it is approaching the free surface. So in the case of open channel flow, free surface is exposed to atmosphere, so it is subjected to natural factors like wind, difference in temperature, pressure, etc. So the maximum velocity occurs at a distance of 0.05 meter to 0.15 meter depth from the water surface. So in this class we have discussed about the difference between the pipe flow and open channel flow. In pipe flow, the flow is taking place under pressure and the pressure is decreased in the direction of the flow, whereas in open channel, water flows with the free surface and the flow is taking place at the expense of potential energy. There are different shape of the channels are available, so we should know the geometric elements, geometric parameters for each shape for analyzing the flow characteristics. So in the next section, I am going to discuss about for the time being it is enough. Thank you. Your SumamMiss.